a 1.5 and 1.7. This is our third test and final test for the quarter. So this is your last chance to really boost your grade. So there's about 12 questions on the test. First one we're going to look at is dividing with i's. When we divide, we want to multiply by the conjugate of the denominator. So what's our conjugate of 4 plus 2i? 4 minus 2i. So the terms stay the same. It's just a sign in the middle that changes. So up top, we have to FOIL. So this was on your guys' last quiz. In the bottom, you could FOIL too, or just use the conjugate shortcut. But let's FOIL the top. 4 times 7. 7 times negative 2i. Negative 3i times 4. Negative 12i, and negative 3i times negative 2i. 6i squared. Then we change I squared to be what? Negative 1, so it makes it negative 6. Perfect. So let's combine the real parts together. 28 minus 6. 22. Negative 14i minus 12i. Negative 26i. Perfect. Over on the bottom, we want to do our conjugate shortcut. So a squared minus b squared. So 4 squared minus 2i squared. 4 squared is 16 minus, don't forget to square the 2 and square the I. So this would be 4i squared. What does I squared change to?
Negative 1.
Which makes it a plus 4. So 16 plus 4? 20. Now, if all 3 of our whole numbers have a common factor, we can divide them. Do we have a common factor here? We can divide them all by 2. So we have 11 minus 13i over 10. So that would be our answer. All right, let's do 3. So when we're solving with square roots, we want to isolate the square root. We got to get the square root all by itself. So what should we do first here? Subtract the 7. So negative square root 2x plus 3 equals 5. What should we do next? Divide by negative 1. So 2x plus 3, square root of 2x plus 3 equals negative 5. What should we do next? Square both sides. So the squared and the square root cancel. 2x plus 3 equals 25. What's next? Subtract 3. 2x equals 22. Then what? Divide by 2. So x equals, what do we have to do with square root questions? We got to check our work. So let's plug it back in to the original question here. So negative, or 7 minus the square root of 2 times 11 plus 3 equals 12. So 7 minus, what's 2 times 11?
22.
22 plus 3. And what's the square root of 25? 5. So 7 minus 5 would be 2. Does 2 equal 12? No. So what do you think our answer is? If the one answer we had does not work?
No solution.
No solution. So always with square root questions, you got to check your work. Now, in the beginning, in this step, we could have seen that it wasn't going to work because we had a square root equals a negative number. If you get a square root equals a negative number, you know that that's going to give you no solution because it's not possible. You can't get a square root equal to a negative. What should we do when we have a square root equals a square root? Square both sides, so they cancel out. So 3x minus 5 is equal to 4x minus 11. From here, we just need to solve. So let's put the x's on one side, the numbers on the other. So I'm going to subtract 3x, move it to the right, and add 11 to move that to the left. So cancel there. What's negative 5 plus 11? 6 equals 4 4x minus 3x? X. So 6 equals x. What should we do? Check our work. Let's plug it into the x's just to make sure it works. So we have the square root of 3 times 6 minus 5 equals square root of 4 times 6 minus 11. 3 times 6 is what? And 18 minus 5? 13. So we have the square root of 13, and then the square root of, what's 4 times 6?
24.
And 24 minus 11? So the square root of 13 equals the square root of 13. Is that true? Yeah. So x equals 6 is our answer. Let's do number 6. What happens when we have a fraction equals a fraction? What should we do to solve? Cross multiply. So 5 times x plus 4 equals negative 8 times x minus 2. What should we do next to solve? Distribute. So 5x plus 20 equals negative 8x plus 16. What should we do next? Let's put all the x's on one side. So I'm going to add add 8x, move it to the left, and we can subtract 20 and move that to the right. So add the numbers to the other side. 5x plus 8x is what? 13x. What's 16 minus 20? Negative 4. What should we do next? Divide by 13. So x equals negative 4 over 13. Can we simplify this fraction? No, so we just leave it like this. You still want to check your work here, but you just have to lightly plug it into the denominators to make sure it doesn't give you 0. If I plug it into our denominator here, negative 4 over 13 minus 2, is that 0?
No.
Nope, so it works there. And then negative 4 over 13 plus 4, is that 0?
No.
Nope, so it works there. So this is our answer. So for number 9, when we have multiple fractions, we need to find our least common denominator. So I want to factor all of my denominators. The first one's factored. We got x minus 3. Second one's also factored, x plus 3. How could I factor our third denominator, x squared minus 9? It's a difference of squares. What would it factor into?
X minus 2, x plus 3.
Awesome. X minus 3, x plus 3. So our least common denominator would be x minus 3, x plus 3. So if it lists twice, you don't have to write it twice for your least common denominator. Now we're multiplying everything by our least common denominator, but what actually just gets multiplied is by what's missing. So what would our first one get multiplied by? X plus 3. What would the second one get multiplied by?
X minus 3.
X minus 3. And what about the third one? Nothing, because it's not missing anything. It's got both of the terms. So when I write out my answer, I have 6, because we multiply what's there by what was missing. So 6 times x plus 3. Plus, here we have x minus 2 times x minus 3 equals, don't forget the equal sign, just 36, because we didn't multiply anything by 36. All right, let's simplify. First thing I want to do is distribute the 6 here. So we have 6x plus 18. How would I multiply the x minus 2 times x minus 3?
Foil.
We have to FOIL. So x times x would be x squared. Then minus 3x minus 2x plus 6. What should we do next? Combine like terms. So I'm going to combine like terms and put it in standard form. So I'm going to start with my x squared. We don't have anything to combine with that. Then let's combine our x's. 6x minus 3x minus 2x would be what? Just x, so plus x. Then we'll combine our numbers. 18 plus 6, so plus 24 equals 36. What should we do next?
Subtract 36.
Let's subtract 36. If we have an x squared and an x, we know that we're going to have to factor. And if we're going to factor, we need it to be equal to 0. So let's subtract 36, move it to the other side. So x squared plus x minus what? 12 equals 0. From here, let's factor. What are two factors of negative 12 that add to 1? 4 and negative 3, perfect. So x plus 4 and x minus 3. So x equals what? Negative 4 and positive 3. So what do we have to do with our answers? We got to check our answers. So let's start by plugging in negative 4. So we're plugging it into our denominators. We just want it to not give us 0 in the denominator. So negative 4 minus 3, is that 0? Nope, we're good there. Negative 4 plus 3, is that 0? Negative 4 squared would be 16 minus 9, is that 0? No. So negative 4 works.
3 doesn't.
Let's check 3. So let me erase this. Let's plug in 3 now. 3 minus 3.
0.
What happens if we get 0 in the denominator? Doesn't work. It's not an answer. So our only answer here would be negative 4. So for the bottom ones, we want to solve, graph, and write your answer in interval notation. So we've got to do all 3 things. Let's start with, we'll do the first one, 11. What should I do first? Distribute. So 38 plus 5x is greater than 7x plus 28. I like it when my x's are on the left because it's going to help me graph it. So I'm going to subtract 7x, move it to the left side, and then we can subtract 38, move that to the right. 5x minus 7x would be negative 2x is greater than 28 minus 38 is negative 10. What should we do next? Divide by negative 2. Now you have to be careful when you multiply or divide by a negative. What happens to our inequality? We have to flip it. So anytime you multiply or divide by a negative, you have to flip the inequality. So instead of greater than, it is now less than. So x is less than 5. So let's graph that. If 0 was here, we'd put 5 here. Now on the test, it's just going to give you an inequality line. I think it'll have tick marks on it. It'll look like this, but prettier, kind of. You can put the numbers wherever you want. If you want to put 5 right in the middle, that's totally fine. Just make sure you're shading in the right direction. So it'll give you a line with tick marks on it. Put the numbers, whatever numbers you want on there. So here I just put 5 to the right of 0. Would it be an open or closed circle at 5?
Open.
An open circle because it's just the less than sign. Now which direction would we shade? To the left of 5 or to the right of 5? To the left of 5. We're talking about x values that are less than 5. So less than 5 would be left. Also, the little inequality tells us that we're going left. So if x comes first, your inequality tells you which direction you're shading. We're shading to the left. But you could always just plug in a number to test. If I had 0 as less than 5, is that true? Yeah, so I'm going to shade in the direction of 0 if it's true. Last thing we want to do is write this in interval notation. How would I write it in interval notation? Awesome. It's going to the left forever, so to negative infinity. To what number? Bracket or parentheses at 5? Parentheses. Infinity always gets parentheses. The number is either a bracket or parentheses, depending if it's an open or closed circle. So if it is a less than or greater than sign, it's going to be an open circle with parentheses. If it's a less than or equal to or greater than or equal to, it is a closed circle with brackets. What should we do first for 14? Let's distribute. So 7 gets distributed. What else gets distributed? The negative gets distributed too. So we have 7 minus 35x minus x minus 3 is greater than or equal to 4. So let's combine the numbers together. Let's combine our like terms. So we have 7 minus 3 would be 4. And 35x minus 6x would be negative 36x. It's greater than or equal to 4. What should we do next?
Subtract the 4.
Subtract the 4. So negative 36x is greater than or equal to 0. What's next?
Divide by negative 36.
Divide by negative 36. What do we have to remember to do if we divide by a negative? Flip the inequality. The inequality flips. So it becomes less than or equal to now. What's 0 divided by negative 36? 0. So x is less than or equal to 0. Let's put this on our number line. 0 is going to be right in the middle. Which way am I shading here? To the left. And is it an open or closed circle? It's going to be a closed circle because it's less than or equal to. Now, if you wanted to plug in a number just to be sure, you can plug in something on the left here like negative 2. Is negative 2 less than or equal to 0? Yeah, so we shade in the left direction. Let's take a look at number 18. So when we have two inequalities, you want to get the number, or the x all by itself in the middle. So you want to get the numbers on both sides, move everything that's in the middle to both sides. What should we do first for 18? Awesome. Since it's being divided by 2, we want to do the opposite, so I'm going to multiply everything times 2. So 1 times 2 would be 2 is less than 3x. The 2's cancel here, so 3x minus 1 is less than or equal to 10. What should we do next? Add the 1. Perfect. So 3 is less than 3x, which is less than 11. What's next? Everything gets divided by 3. So 1 is less than x, which is less than or equal to 11 over 3. Now when we put this on the number line, what's smaller? 1 is smaller, so 1 will come first, then 11 over 3. At 1, do we put an open or closed circle? Open. At 11 over 3, do we put an open or closed circle? Close. What's the number in between 1 and 11 over 3? 2. So let's test 2. Is 1 less than 2? And is 2 less than or equal to 11 over 3? So where do you think we're shading? In between. Since it works, we shade in between. How would I write this in interval notation? Parentheses 1. 11 over 3 bracket. Awesome. So you could either make them have a common denominator. So 1, if I gave it a common denominator to 3, what would 1 be? 3 over 3. So looking at the numerators, which one's bigger? The 11. Or another way that you could do it, or think about it, how many times does 3 go into 11? 3 times with 2 left over? Yeah. So it'd be 3 2/3. So you could turn it into a mixed number to see what it's going to be. What should we do first? We got to subtract 18. If we have an x squared and an x, we know that we have to factor. So we want everything on one side. So x squared minus 3x is less than or equal to 0. Oops, minus 18 is less than or equal to 0. From here, let's factor. What are two factors of negative 18 that add to negative 3? Negative 6 and positive 3. Perfect. So we have x minus 6 and x plus 3 is less than or equal to 0. So x minus 6 is less than or equal to 0, and x plus 3 is less than or equal to 0. So x is less than or equal to 6, and x is less than or equal to negative 3. Now, because we have two answers, we can't really follow the signs that we have here. We are either shading in between or outside. Which one's smaller? -3. So -3 would come first. 6 would come next. Do we have open or closed circles here? Closed circles, because it's less than or equal to. Now, if it's less than, do we shade in between or outside? So remember, if it's greater is outside. Less than is inside. Less than is inside. So we're shading in between. Now you could always test a number to see if that's true. What's the number in between -3 and 6? 4 or 0. 0 would be the easiest one to do the math with. So if 0 is in between, you could just test that. So we don't follow these signs anymore. We are really only care about the one from the beginning, or because you always want to put your x's on the left, so we care about this one. So if it's less than, when you have two answers, if it's less than, you're either shading in between or outside. We can test it just to be sure. If you don't remember that greater is outside and less than is inside, let's test a number. We can plug in 0. So 0 squared minus 3 times 0 is less than or equal to 18. So 0 is less than or equal to 18. Is this true?
Yeah.
Yeah, so that means we shade where 0 is. So we shade in between.
So it doesn't matter, like the answer that we worked out.
So these signs aren't going to matter.
You just use them to plug in.
Yeah, you just use them for the numbers. So if you wanted to even just set it equal to, we're just finding the numbers here. When you have two answers like this, you're either shading in between or outside, so just test a number to figure out where. How would we write this in interval notation?
Bracket -3.
Bracket -3
6 bracket.
to 6 bracket. Awesome. So these would be our two answers. All right, let's do 20. So here we have x to the third power, so we might have 3 answers. What should we do first?
Subtract 3.
Let's subtract 3. So 2x cubed plus 3x squared minus 2x minus 3 is greater than 0. When we have 4 terms, how do we factor? Grouping. Make sure you know how to group for the test tomorrow. So we want to group the first 2, group the second 2. What's the GCF from the first group?
X squared.
X squared. So I'm going to take out an x squared, and I'm left with 2x plus 3. What's the GCF from the second group? -1. Remember, the inside parentheses have to be exactly the same, so we want to take out that negative to flip the signs. So then we have 2x plus 3. It's greater than 0. So the two outsides are going to go together, so we have x squared minus 1, and then the two insides go together as 2x plus 3. Can I factor this anymore? Two x minus 1 factors into what? What's special about it? It's the difference of squares, so what does it factor into? X plus 1 and x minus 1. Perfect. And then we have 2x plus 3 is greater than 0. So here we're going to set each piece greater than 0, but remember the greater than 0 doesn't really matter. If you want to say equal to 0 in this step, that's fine too. So x plus 1 is greater than 0, x minus 1 is greater than 0, 2x plus 3 is greater than 0. You can, if you remember the plus or minus, you can definitely do it that way. So x is greater than -1, x is greater than +1, and x is greater than -3 over 2. Remember, you have to subtract the 3, so we get -3 and then divide by 2. Now let's put these on a number line. What's smallest? -3 over 2 is smallest. If we divide 2 by 3, we get -1 and 1/2. So that would be our smallest number. So -3 over 2. If we divide 3 by 2, goes in 1 with 1 left over. Then we have -1 and +1. Now we want to test values to see where we're going to shade. So let's just start with the left side. What's a number that's smaller than -3/2? Which would be -2. George said -4/2, which would be -2. So that works. That's smaller. Let's plug it in and see what we get. So I'm plugging it into my original question up top. So we have 2 times -2 cubed plus 3 times -2 squared minus 2 times -2 is greater than 3. -2 to the third power would be what? And -8 times 2? -16. -2 to the second power would be +4 times 3 would be 12. And -2 times -2 plus 4. So -16 plus 12 would be what? And -4 plus 4? Is 0 greater than 3? No. So it's not true, so I'm not going to shade over here. Now, in between -3/2 and -1, we only have fractions. There are no whole numbers in between there. So I'm going to skip there, because if I didn't shade in the first one, I'm probably going to shade in the second, because they're going to alternate. But let's test a number in between 0 and 1 just to double check our work. What's a number in between what's a number in between -1 and 1? 0. I kind of gave it away, but 0. So let's plug in 0. 2 times 0 cubed plus 3 times 0 squared minus 2 times 0 is greater than 3. So when we multiply everything by 0, we end up with 0 is greater than 3. Is that true? No. So we're not going to shade there. So like I said, we're going to alternate. It always has that alternating pattern. Let's just double check our work. Let's plug in something greater than 1, so 2 would be perfect. So 2 times 2 cubed plus 3 times 2 squared minus 2 times 2 is greater than 3. 2 cubed would be what? 8 times 2? 16. 2 squared is 4 times 3, so plus 12. -2 times 2? 4 is greater than 3. 16 plus 12? 28 minus 4? 24. Is that greater than 3? Yeah. So it works here. So that means that it's going to work here. It alternates. At my numbers, at my key values that I had here, so -3/2, -1, and 1, do I have open or closed circles? Open, because it was just a greater than sign. So open circles. And we're going to shade in between here where it works. And we're also going to shade over here to infinity. 2 worked, yeah. So that's why I'm shading over here.
Don't shade where it works.
You shade where it works.
That's probably like if you plug in -2 and it works. Right?
-2 didn't work. So I plugged in -2 first. It didn't work. Same with 0, did not work. Let's write this in interval notation. What would we start with? It's our smallest number that worked. -3/2. Bracket or parentheses? Parentheses. And then that went to what? -1, parentheses. When you have 2 sections, we put a little u in between. What else worked? 1 to what? Infinity. Perfect. Just for extra practice, let's say we had a question like x squared plus 5x equals 0. How would I factor this? GCF. Take out the GCF. What's our GCF? X. And we're left with x plus 5. So then we would just set each piece equal to 0. So what would x equal? 0 and -5. Awesome. So don't forget, if you have something like this, take out your GCF. Always the first thing you should look for if you are factoring, do you have a GCF? Because even if your GCF is just a number, it'll make your numbers smaller, make it easier to factor.